What's up, Bob? How you doing?
Good to see you, Joe.
Likewise, yeah. By the way, congrats on the new book. I get that out of the way, Datapreneurs.
Great.
Yeah,
Thanks for
yeah,
getting a digital copy there.
yeah. And get the physical copy in the background. This is audio, of course, so the audience won't see it. But great book. And I was intrigued, sort of about your take, which we can talk about. But that's why I wanted to talk to you more about it. But first of all, what got you interested in writing a book? It's kind of a lot of work, and
It
um,
is a lot of work. It was more work. I think if I knew how much work it was, I'm not sure I would have done it, to be honest with you. That's
okay,
the thing I'd say. But it was a lot of work. And it's not something I'm particularly good at either, if that makes sense. I'm not an author. That's not my my reason for existence in life. But it was, I felt like I had something to say. I felt like there was a lot of things that I learned over my career, and a lot of people were asking me for what I think on a variety of topics. I figured I'd write some of it down and do it in a way that hopefully people would enjoy, by talking about the experiences that I had
Mm,
working with these incredible entrepreneurs, data entrepreneurs, my whole life. Even when I was at Microsoft, that was my one realization, that I was
yeah.
working with entrepreneurs when I was at Microsoft, even though it was a very big company. And I was typically building new products while I was at that at Microsoft. So I've been doing this most of my career, and I thought there was things that people could learn. I think everyone will learn something in reading the book. I mean, I think that's true.
Hmm.
And hopefully people find it enjoyable, and they get something out of it.
Yeah, for sure. I know. I read a lot of data books, and I think I learned a ton. The amount of underlines I have is pretty crazy. I just think you bring a very unique perspective to the industry. You've been working on databases since like the '70s or something.
Yeah, I've been
So,
building apps basically. I
yeah,
mean, it started as an app designer, and building early apps on, in the early microprocessors, originally on Z80 microprocessors. And then I built a database, a data collection system on the first IBM portable PC. Way back when back in the days when when IBM was the king. And this is the early 1980s. This is the early
hmm
1980s. So
walk me through that time. I mean, because I think it informs sort of the direction of the book and the conversation we'll have. But what was the database and the application world like back then?
it was very fragmented, and it was the tools were very primitive. SQL really, this is, I talk about this in the book. SQL was a real amazing breath of fresh air to the development community, because the earlier databases, which are typically hierarchical or network databases, there were some early relational databases, but they never really caught on.
Mm,
And the only relational that ever really got traction was SQL based databases. And when SQL came out, the fact that you could do transactions at high consistency level, you could modify data schemas, those are all revolutionary concepts. The prior generation of databases were very physical in the way you interacted with them. When you were
mm,
saving data in a network database, you had to persist all the relationships and things. And it was a lot of laborious work. And then trying to do things like change the schema was almost impossible. Trying to do a report was
mm.
very difficult, because you'd structure things for your application, and that was not structured in a way that you could easily extract data for a report. And relational just changed all that and made it so much easier. SQL made things so much different. And so that's why it really dominated starting in the 1980s, and it's still quite dominant to this day.
Hmm. Walk me through this, though, because it's something in my own research. It seems like there was a period of time when databases might have been up for grabs, really, because you had hierarchical network and relational databases, and um, it, correct me if I'm wrong, but it seemed like that it was sort of up in the air as to which ones would win.
It was, but it in the 80s, it seemed to take shape to me. I mean,
Right?
because you saw Oracle, you saw IBM. First, IBM was a little reluctant. They built System
Yeah.
R, and they were a little reluctant with it. They came up with DB2, slightly later, not that much later, and they really got behind the relational architecture in SQL. Oracle obviously had a huge job, huge role in
Hmm.
popularizing SQL, and established in the early 1980s the first really major independent database company. In that time frame, we had a lot of SQL databases, Informix, Ingrix, a whole set of these things that were companies that ultimately have disappeared over time. Sybase was the company I worked very closely with, because SQL Server, Microsoft SQL Server, derived from the Sybase code base
Right.
originally. So
Yeah, that's interesting. Yeah, I think that's one of the things I found interesting about your book was just the kind of the first person viewpoint of the history of databases. I'm a history nerd, so this is like very, very, it's very, very interesting, right? But then,
Yeah, I mean, I mean, I was fortunate to be there for a lot of
yeah,
it. I'm old enough to have been there for a lot of it too. So
yeah. The only other person I know who is really who I talk to a lot is who's around the time is Bill Inman, and
mhm.
he had sort of a different take on stuff, but I think he echoed a lot of the same things where it was very fragmented. IBM dominated the universe back then, and then it's sort of the 80s kind of up for grabs. But that's
Yeah, things change. I mean, the IBM PC was a huge step forward because when it came out, I mean, it enabled a large number of different companies to build things. We at Microsoft took advantage of that new hardware platform with ultimately Windows Server, and products like SQL Server that were built on top of it. And what we saw in that was the 90s at that point in time. I
yeah,
would say that's when that's became really got some traction. And that was the time frame when these systems were spreading quite a bit.
hmm
I would say the 80s were the days of the birth of SQL solutions, and large companies were implementing applications. In the 1990s, and I give us a lot of credit at Microsoft, we took the database and we democratized it and made it available at a much lower price point, and enabled people to run a small business on a database system. You got to remember, go back 30 years. Every dentist office you went to was all paper and pencil. I mean,
right,
even 20 years ago, a lot of them were still paper and pencil, and almost every small business was in that state where they really didn't have business automation systems. And it was products like SQL Server that changed that.
right.
And Small Business Server, which was a product that my team built, which put all these things together in one very relatively easy to install package. But back then I used to say, the first thing you had to do was you had to clean the mouse turds out of the closet, and you get the network. I mean, it was a very different world back then. It was a very different world back then than it is today in the services
It is
world.
a very different world. Yeah, now you have the cloud and everything else. So, I mean, a question I've always wanted to ask somebody like yourself is, what makes a great database?
This is very interesting because I was thinking about this in the context of some different databases. I don't think databases should be Swiss Army knives. I just don't think that's what, and it's interesting. Early on, we thought they needed to be to some extent because we thought there would be one database sitting underneath an application. What happened is that the technology clearly bifurcated, where you have databases that are good at operational workloads
Mm,
and very high interactive, very high transaction volumes. And they have databases that are very good at analytics and working with very large amounts of data. And I kind of give Teradata the credit for establishing that separation. And that happened in the 1990s when that began
right.
to separate. And you put a pipeline between the two. So I think you focus on doing something and doing it well. And you can connect multiple systems together. And I think we're going to continue to see that. I don't think we're going to have, the one database to rule them all. I just don't think that's going to happen. And even with, people adding transactional capability into analytic systems like Snowflake is doing, that's not going to replace. I mean, it's not going to replace all the operational databases. It may be
Right.
great for enabling you to build complete data applications and building
Mhm.
analytical apps, but you're not going to replace your order entry system with, in some senses with those things. I don't think.
That'd be a lot of mouse threads to clean out of that one. So,
Well, Snowflake. The thing is, you have to realize Snowflake. You take Snowflake; it is incredibly tuned to do what it does.
right.
And you can make these things work, but in essence what Snowflake is kind of doing is they're bolting two different systems together
hmm
in some senses, and making it work as a seamless service. And that may be great for some. It will be great for some. It'll be absolutely great for some applications, but the world needs different systems. And this is why I've been focusing, for example, on this idea that operational applications that, by the way, when I think of operational apps, I tend to think of people applications. I call them people
Mm,
apps sometimes, because there are apps that you use that are designed to interact with people. That's what they're designed. And most of our apps are that way. Let's face it. I mean, that's what they were built for. we now have a new class of applications, data apps or intelligent apps, that are apps that respond to data and sit essentially at the top of the analytics stack. But underneath all of that is the data collection from people. And I think what you need for that is very, very different than, for example, what you need in different parts of the stack. And one of the areas of focus I've had recently is this view is to really build a product that is an operational database, which has the characteristics that are needed in today's modern applications. Because I don't think SQL databases are well aligned with that, because of the static nature of tables and the challenges associated with schema migration inside an application. And in today's world, where you have dynamic applications, where product teams are analyzing data and looking at what's happening and making changes to the application on a continuous basis, the front end systems that people use, typically JavaScript based applications, often using frameworks like React, those are very flexible. They have dynamic typing. Now with TypeScript, you have the ability to incorporate static typing and essentially do gradual typing of your application. So you can experiment and work with your app in dynamic ways, and yet harden it at the same time as you begin to understand the characteristics. Those have all modernized in the front end systems. The back end systems are not that way. They're still static with SQL. And I think it's time to change that. And that's what we've been working on at Fauna. The Fauna team is focused on building a fully relational database, that uses a semi-structured or document data model. So it's highly dynamic in its structure, but then it also has the ability to incorporate static types, so that you can do validation and things like that, and ensure the quality of the application. But that data model, I think, is more appropriate, because if you look at the forms and things that people work with, they're naturally hierarchical.
Right.
And the data models that we need to put them into in SQL are very different than the data model of the application. And the really cool thing about a database like Fauna is the data model of the database is the application data model. Because when you serialize a modern language into a format, a format you can save, it looks semi-structured. And that to me is really interesting.
It is really interesting. The I actually caught this on a show you did with Kent Graziano, but I think you have some pretty strong opinions on SQL as well, right? And I think it feels like it got us here, but it's maybe has some limitations you'd be willing to describe.
SQL, people should realize that the first thing to realize, and I think it's real, and I think that this is my mantra of the fall, which is relational is more than SQL, and SQL is great. I mean, let me just start by saying I love SQL. SQL has been very good to me. I love SQL. When we built Snowflake and we're creating it, part of the reason why we were able to be so successful is because of SQL and the base of knowledge and everyone has with SQL. But the interesting question is that the end all? Is that really the end all of databases? And SQL is a database language. It is built, on top of relational concepts, but it does not include the full relational algebra or relational calculus. It's a superset kind of it in some ways, and it was built in, it was designed in an era literally 50 plus years ago, and the algorithms that our SQL databases are using, and they all use very similar algorithms, are based primarily on a binary join. You take two tables, you have a key, you join it together, you get a result set, you do it again, you do it again, you do it again, and that's your query plan. That architecture made total sense in a memory limited world. But when you've got gigabytes and gigabytes of memory, why can't we do multi-way joins? And the answer is you can. It's just a different algorithm than all of these systems use. And so there's an opportunity to break free of the box that SQL has put us in. And that box really starts with the table. And the idea that the primary object you're working with is tabular. Well, the relational algebra can work with objects of any shape. I mentioned semi-structured objects in document, and that's a very natural form for relational to apply to. But it can also apply to graph type data structures. And in fact, that's where this idea of knowledge graphs come in and relational knowledge graphs using the power of the relational mathematics to enable you to work with database objects that map more closely to what you're really trying to do. Today, we take a business and the requirements of a business and we take that and we model that in data, a part of it really. We model the data in a tabular format. That's great. And we're going to continue to do that. But what about that business? And what about the business logic and all those business and semantics? Where do those live? The answer is those semantics of the business. They live in documents, they live in people's heads, they live in Slack messages, they live on whiteboards. They live inside business applications in code that you may never have seen. So they're quite opaque to you. And I think we're going to move to a world where we're much more explicitly modeling the business and the database. And we'll have, in a few years, a new generation of databases, these relational knowledge graphs that will allow you to do that. So in essence, what I'm trying to do is say SQL's great, and we should use it for what it's good for, which is highly structured things. That's structured applications. Like as I said, if I was going to build another general ledger system, I'd use SQL because GLs don't change very often. If I was going to build a billing system, I would want to use something like Fauna because it's a much more dynamic environment. And, you want to be able to change the way your programs, your marketing programs and all those things on a highly dynamic basis. And the static nature of the database makes it quite an obstacle. So that's on one side. And if I'm going to do data analysis in the way we do business insights today, I would use the slicing and dicing capabilities of SQL to work with vast amounts of data. But if I want to do much more detailed processing on some of that data, for example, graph type processing, all SQL databases fall down and are incapable of doing it. And today we really don't have in the market of a relational based graph database. That's going to change. Next year, I think it's going to change with RAI shipping on top of Snowflake. Relational AI is this company that's building a knowledge graph. I think that will change next year, and it'll be possible to model a business inside the database.
That's really fascinating. And where do you think generative AI plays into this, right? Because it seems as you described things like Fauna, for example, when you're talking about fully relational, but with a document structure, like what prohibits you from including other types of data in that graph as well?
Nothing. And there's a couple different aspects. Generative AI plays a role in being able to help, obviously, people write these applications. One of the great things is that it allows, if I sit back and say, hey, we need something more than SQL, that implies that we need new languages that are different than SQL in some way. Fauna has introduced a language called FQL, which is really designed to work with these semi-structured documents relationally. It's the first relational semi-structured document language. Relational AI is using a language called REL, which is a very flexible, super flexible relational language. You can literally model anything in REL, and it's insanely powerful. One of the big challenges with all of this, particularly when it comes to business modeling, is I've come to the conclusion that it's very complicated for people to be able to create these models. And I think, when I said, where is the business model defined? Well, if it's defined anywhere, it may be in people's heads, but if it's anywhere, it's written in their native language. Let's just say English. So English and other native languages become very important sources of knowledge for the knowledge graph. And now, and honest to gosh, I spent 2 years working with Mulham and Arif, who's the CEO of Relational AI, talking about how we're going to be able to take this knowledge that's in today in documents and everything and put it into this relational knowledge graph. These large language models are an incredible breakthrough in helping with that, because they can scour that information, summarize it, and then put it in a form that can help people to understand what's going on and encapsulate that in the business. And more, I've come to believe that we will define a semantic layer of the business. People are talking a lot about semantic layers. They often refer to the data layer and defining a semantic data model for for the data. And that's critical because, as you know, people are trying to build English-based query languages to allow business BI tools to just use English. And I think what everyone's finding is that you can make a great demo. You can do a great demo with 4 tables and things, and it looks fantastic. But when you actually try and do it in the real world with the complexity of what people are dealing with, the large language models struggle to get it correct because they don't fully understand the semantics.
Right.
So we need to provide a semantic model for these large language models to work with. And I think there's a very simpatico, because we talk in English, the knowledge is documented in English and other native languages. Ultimately, you're going to call a SQL database, to format and create the data and model the data. How do you get from here to there? The large language models can help, but they can also help in building the semantic model that will help to define, how those queries get built in the future.
It's really fascinating. So one thing I've been wondering about is there are all these, I guess, kind of enterprise-y practices, right? Like data management, governance, quality, and so forth. Everyone talks about wanting to do them. Mixed results so far. Yeah.
It's not so good most of the time. I mean, governance is my favorite topic of challenge right now.
Yeah. It's one of those things. I definitely feel it's like good hygiene. Everyone talks about it. It's hard to do out of habit. But how important do you think it is to get this right? Things like governance, quality, and maybe things like data ops,
it's life itself. I mean,
right.
It's the most quality of high quality data that is only accessible to the people that should access it, because that's the main part of it, right? Is there's a lot of information in data that only some people should see. Let's put it that way.
Right.
And it's really important that the governance and access control mechanisms are well established. And it is really hard for customers to do this right now, like really hard. And to me, this is one of those unsolved problems that I want to help customers with. And I believe, see, again, I have this view, which is the solution to this problem is a semantic model and a business and understanding the business model. So I come at it from the perspective of first principles, which is that I need a database that can store the semantic model for whatever for the business or for the data, a semantic model for the data or a semantic model for the business. And honestly, the world does not have a production class database that can store the semantic model for a business or the database. I mean, right now, the state of the art is essentially, to a JSON or XML file, and maybe stuffed in a document database someplace. It's not the right technology. It's not the right technology.
I love your perspective on this too. I feel like right now discussions of things like semantic layer, I think they're in the right direction. Like we're starting to focus on sort of having an abstraction, of the different terms and whatnot. But it's focused very much on the analytical piece right now, right? And it feels like this really should be a cohesive thing across the data lifecycle.
Because people are talking about the data, the semantic model. The distinction, it's very simple. There's the distinction of the semantic model for the data, which is about the analytics. To me, that should derive from the semantic model of the business, right? And I've made the statement, I continue to make it, that 5 years from now, data ops, people who are in data ops, are actually going to be in business ops. And that's what it's going to transition to, is to understanding the business. And then from the business, which will be incorporated in a knowledge graph, we will derive the semantic model for the data, which will also be in a knowledge graph, which will then support the underlying data model, which will remain in a SQL database for quite some time.
Right. I think you had something similar when you talked about data engineering. I think in one podcast you were on, you said that data engineers are going to be a
data ops, data engineering. It's the whole,
fully agree too. I mean, I think my brand name is associated with data engineering, but I also wrote in the last chapter of my book that I think it goes away at some point because as there's more abstraction, right?
Well, I think it becomes business engineering.
Yeah,
I mean,
exactly.
I don't think it goes away. I think frankly, I think it transitions into a more important role.
For sure. Absolutely. Yeah, more value add stuff up the food chain versus like managing pipelines down below and just doing low level stuff, which I think is increasingly, it's either automated or
It's
abstracted
getting
away.
easier. It's getting
It's
easier.
way easier. I mean, so one thing I've been wondering, you've been in the game for a long time. Like, did you ever envision working with data would be this easy?
Is it easy?
It's easier.
It's easier.
You're not cleaning mouse turds out of a
You're
closet
just saying
anymore.
you're just telling me I did my job in essence. Yes, of course I did. Of course I did. That's what I've been doing my whole career, is trying to make it easy for people. It's
Right.
always been too darn hard. I mean, I feel like, look, I feel like we took a big step forward in the 1990s when we did Small Business Server, for making it easy to work with data for small business companies. I mean, that was a big step forward. I mean, look back on it, looks awful primitive, and I wouldn't want to set one of those up today.
Right.
But man, let me tell you, in 1997, it was pretty cool. And and when we did Snowflake, the problem that everybody dealt with was there was no database system that could handle all their data and all their users. And so people, every company of any size fragmented their data into multiple silos because they had to, not because they wanted to, but because no single system could handle everything. I mean, the only systems that could really scale pretty well were Teradata,
Right.
and maybe Netezza, and both of them had their limits too. And to make it work, to make Teradata scale, you had to spend enormous amounts of money with white gloves, and it was a true IT piece of DBA sort of work to keep the thing working. We took a different approach with Snowflake and said it should be easy to run this as a service and work with data of any scale and any number of users, and in doing so, really took the whole industry, I think, a big step forward. Now, what I'm saying is, okay, you say it's easy. I say, hey, you want to work with a graph problem? I mean, what are you going to?
Right.
You have a graph problem you want to solve. Tell me how easy it is to solve.
Right.
it.
True.
So I'm focusing. I'm not focusing on the problems that are solved.
Yeah.
I'm focusing on the problems that are not solved, and taking the things there. Yes, I'm so glad you think it's easy. I feel like I've done my job.
For that set of problems, yes.
And now I'll talk about the problems where it's not so easy, right?
Right.
My favorite problem that I ask everyone, you think you've got decent governance. Riddle me this. Fred Jones was just terminated from your company this afternoon. He was, he's out of Okta. He's been removed from your system, so he can't get anything. What data did he have access to?
Mm-hmm.
I don't think anyone can answer that question. I mean, how would you answer that question?
It's hard. And you usually find out the hard way.
I mean, you could do a lot of work and get a pretty good idea, but why can't you just run a query to answer that?
Mm-hmm.
The reason you can't run that query is because there is no database today that can run that query. I mean, you might be able to run it in TigerGraph or Neo, maybe, if you structured something specifically there,
Mm-hmm.
but you can't do it in Snowflake.
Right. Back to Snowflake real quick. I mean, you were CEO of Snowflake for a while. I remember when you guys first came on the market. It was crazy because your sales team somehow knew how to talk to the enterprise. The product was geared towards a certain type of customer. It's like you guys hit the ground running, knowing who to go after with the right type of tool. Like how did you guys do that? Because the moment I talked to you guys, I was like, these guys get it. They're going to go places.
I think that we were benefited because both myself and our founders, Benoit and Terry in particular, were in the enterprise for a really long time in building enterprise products. I mean, I spent a good part of my career at Microsoft trying to make Microsoft an enterprise player, right? Because we were never really an enterprise player. We were more of a mid-market player.
Yeah.
And it was really the work that the server team did, et cetera, that continued to ingrain Microsoft more and more in the enterprise. And now, of course, with Azure and the cloud, it's very, very common. So there was a lot of DNA in the people that understood these things. And, and I don't know that we really knew exactly how the product would be used at first, because we definitely felt like we were throwing spaghetti against the wall on the early days. Getting leads was our hardest problem.
Interesting.
Early on, people didn't believe us. We were saying something that was unbelievable. We were literally, you would do these customer presentations, And customers would say to you in the middle, I know you're lying. I know what you're telling me is not true because I've been doing data warehousing for 20 years and I know they don't work the way you're talking about. At which point you'd spend 45 minutes on the architecture slide with them.
Right.
And most of the time you won them over. They were like, really? Does it actually work? And they're like, yeah, it works. And then they're like, why doesn't everything else work this way? Well, because it was impossible before it was built. Before the cloud existed, it was impossible to do this. And we built it after the cloud. These other databases were built before. So those are the sort of challenges we had early on, was demonstrating to the enterprise that it was a real product. But the one thing I would say about Snowflake is more than any other product I've ever been involved in, that was a capital E enterprise product from day one. I mean, a product that can literally handle the data of the largest company on the planet in a single system. It never happened before. I mean, and that was always, our promise. And sure, it took us a while to really get to the point where we scaled to work with a giant enterprise. But it only took a couple of years to get there because the product was designed from that objective from the beginning.
That's really interesting. So it seems like you're really good at spotting inflection points, right? I mean, I don't know. It seems like you have a sixth sense about this. Snowflake, you work at Microsoft, and then the stuff you're talking about with Fauna and relational AI. Like, how do you spot inflection points?
Well, you start by, I think what you do, in my case, I'd say is really simple. I mean, I listen to customers is probably the number one thing. And I've always believed this starts with the customer and ends with the customer. It's always all about the customer. That's why Snowflake's first value is to put its customers first. And we really meant it to them. It was very important. It's such an important thing to deal with values and to start with that. But by listening to customers, it's not working. And you say, well, how can that be fixed, or what could we do? And and if it's a small change, great. You just add the feature. Most things are just features, But then occasionally you see something like a graph data problem, where you hear that customers are having these issues. They really want to solve some problems, and they don't really know what tools to use. And that's an opportunity. And then the question is, what's the technology that's going to fill that opportunity? And I've got enough preview of the industry to be able to sort through those sorts of things and make reasonable determinations about what is a high probability of success. Things like relational AI, they're not guaranteed to be successful. I mean, it's still too early to know that, but I know that what they're doing, is so algorithmically advanced that I'm confident that that's the right direction. And I have in the past whiffed on early insights. Let me give you the most classic example of one of my whiffs was the Microsoft tablet. Okay, I owned the tablet group in 2001, 2002 at Microsoft, and we were building these tablets, right? With these OEMs, NEC, and these companies building, pretty decent looking tablets.
I think I saw the demo and they look cool. The video of it.
It didn't work very well.
Yeah.
And the reason they didn't work very well is because we were focused on the pen as the primary input. And in part, to be honest, that was because, our leader, Bill Gates, is a note taker. Bill loves to take notes. He takes notes all the time. And so he loves having some pen. How many people take notes with a pen?
I've actually seen this before at the Berkshire Hathaway meeting. Bill was on the board of directors, and the entire time he'd be sitting there scribbling on a legal pad, scribbling.
And he does notes. He's not scribbling on a tablet. I don't even think to this day he's scribbling on a tablet. He's scribbling on paper.
Paper. Yep.
And he loved to take these notes. Well, the tablet required multi-touch. And Apple invented that, and once that was available, all of a sudden this became a very viable solution. Just like the phone, it unlocked the capability of the phone with multi-touch, and so you sometimes miss things because you've missed a key characteristic that has to be in place. Often, if you look at Microsoft classically, we were ahead of our time, but we missed some key attribute, and as a result, just missed the market. And the tablet is a pretty good example of that. But I happen to have fingerprints all over.
Except the demos are really cool, and I saw the videos. It's like,
they were cool.
I hope this come out, yeah.
But you couldn't really use it. Did you ever try and use it for a while?
I never got a chance to check it out. No.
I love my iPad. I mean, I use it for watching television. I read 80% of what I read on an iPad.
Interesting.
And, I really enjoy using that device. I don't use it for, for heavy work. It's not good for doing heavy work or PowerPoint or, slides or something like that. It's not good for that, but it's good for so many things. If you tried to use the Microsoft tablet, after about 3 days, you'd put it down and say, I don't need this thing. And that's what pretty much everybody did.
Have there been any equivalents in the data world? Any key whiffs there?
Sure. I mean, there was all the object databases of the 1990s. I mean, and this is if you want to talk about trying to, this is my favorite conversation. One of my colleagues, George Fraser who's the CEO of Fivetran. George, I love George because he's brilliant and he's very vocal. And, George will tell you that when, Captain Kirk asks to find the next star, them to find the next star to move the Starship Enterprise to, George thinks that's a SQL query that's executed. And he's very clear. He thinks that's a SQL query. And he and I have an argument. I don't think we'll ever be able to pay off this bet one way or another, because I don't think either one of us will see this, but that no, it will not be a SQL query that's determining the star field to go to in the Enterprise. But George is great because he loves SQL, and I think SQL has proven again and again to be able to expand. I think it's at its end right now because these are fundamentals of the structure of the data. When people tried to do object-oriented databases, this was a realization that there was an impedance. This is the 1990s, if you remember.
Yep.
There was an impedance mismatch between modern languages at the time, Java, and a relational SQL database, because you would model your data typically in third normal form, and your internal data model is a hierarchical model. And so we built these ORM layers that do the translation, and they're ubiquitous and people use them all over the place, but they're not ideal. SQL has been very flexible. I'd say it's been incredibly flexible because people have added things in. I think we're reaching a point where some of these things we're going to decide we need to break free of that, though.
In your book, you talk about a model-driven world. What is that?
It's the world we're living in now, or about to live in. I mean, it's a world where essentially we're modeling everything, both explicit models for physical things, which happen a lot today. I mean, today, if you were designing any sophisticated device, even a modestly sophisticated device, like a thermostat, okay? A thermostat's kind of an interesting example of a device that you think it was pretty simple, but these Nest and these Ecobee things are pretty complicated these days. If you were to build something like that, or anything more complicated, a car, a bicycle, one of these electric bikes, goodness, an airplane, you model it today, and you use a variety of modeling tools. And people talk about building digital twins today of physical devices. That's one of the areas I'm focusing on. One of my companies, Julia Hub, is focused on, in modern language, for engineering modeling, basically. And most of this work is done in using MATLAB and Simulink. And that technology is looking pretty old right now. And there's a tremendous opportunity using a much more modern language like Julia to totally revolutionize the modeling of physical devices. And recently, Julia Hub just connected with Boeing and is working very closely with Boeing and the aeronautics industry on the many, many challenges that exist. And aeronautics is going through one of the most interesting transitions of my lifetime. The 1950s and the early 1960s were the golden age of aeronautics, and things have stayed fairly static since then. I mean, the jets have gotten more efficient, but they're pretty similar to the ones I flew on, in the 1960s. They were actually faster in the 1960s than they are today, believe it or not. But now we have all these electric airplanes and UAVs and all the drones and all these things that are coming. So aeronautics is incredibly interesting because we're going to have robots flying through the skies. I mean, that's one of the first places robots are going to appear is in the skies, because they're already appearing in the way of these drones. And so you have to model that with digital twins. Well, we're starting to model businesses in digitally as well. And when I talk about building knowledge graphs that model the business, that's very much a digital twin of your business that you're creating. And of course, all of this, the artificial intelligence things that are happening, those are also models. Those are statistical models, that are built using, neural networks typically, and those are also playing a very key role in the model of a business. So what's happening is modeling is replacing in some ways software, and that's why I say, going forward, software is eating the world, but modeling is going to eat software in the next 10 years.
This is really interesting. It echoes some of the talks I've been giving. I was just in Australia. I just got back from there, giving a talk about data modeling is dead, long live data modeling. And really, it's a call to arms to get back to thinking model first. Because I feel like right now we tend to implement models at a physical level, right? If it's Snowflake, hey, separate compute and storage, I can just throw as much compute as I need to at the data. The data is cheap to store, so like, why do I care about thinking about the data? Just throw it in and query it and be done. But the things I've noticed is a lot of the representation of the business itself is lost in this whole practice.
No,
right?
it's nowhere.
So,
where is it?
bingo.
People's heads. It's in apps. It's on Slack messages. It's, in a document somewhere.
Mm-hmm. Yeah, that's a key insight too, is the fact that the information is disparate too, and it's what I also find in my observations is there's this whole other parallel universe. I call Excel the dark matter of data. Right, it's everywhere, but you don't see it.
The most incredible and horrible tool ever created by mankind, arguably.
Yep.
Excel is clearly the greatest app ever created, and perhaps the worst app ever created.
Well, if it's what I find oftentimes is, we have this great modern data stack, provides a lot of utility to data teams, but often there's a decoupling of the data team and the executives who are making decisions. I can't even tell you how many times I've been in meetings with executives where they're making decisions off a spreadsheet that had nothing to do with the data that was in this modern data stack.
That was the classic history, right? I mean, that's the world I lived in.
Right.
When I was running server and tools at Microsoft, that was the world. There was literally an army of data analysts that stood behind my business to help understand the business, and it was all done in 2008 on Excel. I mean, Excel was the tool that we were at Microsoft, especially, but Microsoft used Excel. It was a mess. And that mess was not just unique. I mean, that mess was everywhere. Every company had a similar mess, pretty much. The only ones that kind of, I look back, the company that I look back on that sort of had it, the Teradata companies that spent all that money on Teradata sometimes were way ahead in terms of thinking about data and running their business on data. But Teradata is so inaccessible to most companies. I mean, it was
expensive. It's so expensive. Yeah. But it's getting easier, right? But it's interesting because I feel like it's getting paradoxically easier to work with data because, as we talked about before, at least the problems that are easy are now easy. But there's still a lot of hard things, right?
Well, that's my point, right?
Yeah.
Again, my career has been focused on helping customers to work with data, and not so much building the applications that they use to run their business. Although I've done that occasionally. Mostly it's in building the infrastructure that sits behind it. And I just have this very fundamental belief that with the right infrastructure, in the right data model, everything is so much easier. And so I'm focusing on the places where, like I say, so the SQL data models and structured data, it works for a lot of scenarios and it's great. Where are the problems? Where are there issues with it and customers are struggling? To me, the areas are in the operational apps and the people apps side. It's the much more dynamic apps, the apps where you need to change things on an ongoing basis. You want the transactional consistency of SQL. You want the full capabilities of the relational model, but the data model, that structured data model that you typically use like a third normal form, is an impediment to running the business because it is hard to evolve. That's where we need to change the underlying database, and that's what I've been focusing on with Fauna. In the case of the data analytics, if you want to slice data, if you want to deal with petabytes of data and slice it and dice it any which way you want, go get Snowflake or BigQuery or something like that, and you'll be very happy. It'll do a great job for you. If you want to solve some of the reasoning problems, if you want to model your business, if you have a graph-oriented problem, what do? There's no good answer. There's no good answer. So that's why I think governance is such a problem for customers, because there is no database to support the requirements of governance. And SQL is not that database. And so we need the database to support governance, and we don't have it. But we will.
I very much look forward to this. One final question. So it's in the back of your book, you have Isaac Asimov's rules for robotics. Why did you include that?
Well, I mean, I think it was in the foundation of what I wanted to do from the very beginning. Mm-hmm. I've been influenced by Asimov since I was a young man. In my teens and 20s, I read most of his books. I can't say I read them all because he has 460 of them.
He wrote a lot of books.
I can't say that I read them all, but I read hundreds of them, certainly. And certainly all the robot stories and most of his science fiction and quite a bit of his nonfiction as well. And he had always had this view that we as a society were going to create machines that would help us in a variety of ways, and that would operate under certain rules where they had to work with us. And essentially the laws of robotics are the foundation, in some sense, of how these machines should interact with people on a day-to-day basis. And if you look at Asimov's stories, they're all really parables. I mean, it's remarkable. These were written in the 1940s and 1950s mostly. Literally, he defined the term robotics, and he created the laws of robotics before the invention of the digital computer.
Right.
It's pretty cool. You got to think that guy was clearly a visionary. I think he was a prophet in some senses, in that he viewed the future. And, he viewed that this is the way these machines would need to operate. They would need to have laws like this to interoperate with people in our daily lives. Move forward to where we are now. I never believed I would see robots. I thought this was coming. I've always believed it was the future of humanity. I thought Isaac Asimov was writing about 2100, 2200. Now I think he's writing about the 2030s and the 2040s and the 2050s, which, interestingly enough, is exactly the time frame he had in his book, by the way. He's like identical. I'm just like, he nailed it. And so I just feel that as we now are creating these large language models that have all of these characteristics of intelligence, and they're beginning to have some of the characteristics that Isaac Asimov viewed about robots way back then, we need to think about how we build these systems to work with us and for us, not against us. And the laws are just one way to view that. We won't implement in a large. I mean, Isaac Asimov had positronic brains that I think were analog in their nature, and the way it worked was built into that brain that they couldn't violate these laws. That's not how our large language models. That's not how our foundation models are going to work. But our foundation models are built on the values that the creators of those models instill within them. And it's really critical that as we create these systems, and I'm now excited that, with open source, things like Llama 2, we're going to see a proliferation of different systems of every possible type. Some of them will be fantastic and they'll be helpful, and there are going to be some nasty bots out there, just some nasty, nasty bots. But that's the world, right? That's the world, and that's people creating these things. I think it's critical that as we create these things, we think about the values that are being imbued within them, and that we work with them in values that are consistent with what we think is important in advancing humanity. That's why I think the laws are important. Not because this are exactly how we're going to do it, but conceptually they're right. They're correct. Yeah. It's just a question of how we implement them in these models. And I think now that for the first time we can bottle intelligence, kind of like Asimov thought about in a positronic brain, we need to think about values and laws. And that's been a big part of my whole career as well, is making sure that companies are built in a values-based way. One of the reasons Snowflake is so successful is they have a great product. Another reason is it's a values-based company, and customers like working with the company.
That's awesome. Well, Bob, it's been great talking to you. I learned a ton. So definitely one of the most animated guests I've had too. I'm tempted to just put the video up instead of the audio. So you're it's a ball of energy. It's really cool to see. So
good. It's good to talk to you, John. This is a fun subject. There's so much going on in the world today.
Yeah.
that it's an amazing time to be in
It
technology.
really is. It really is. It feels like it's the old Lenin saying, you have years where nothing happens and then weeks where decades happen. And that's
Certainly 2023 has been where, it's been an incredible year of progress. It is fascinating because I do feel like we're kind of through the hype of AI,
Yeah.
and we're now entering into a period where we're waiting for products. I mean, in Gartner terms, we've hit the peak of the hype cycle and we're beginning to enter the trough of despair now. Right now, I think it's going to be a very fast trough of despair, and we're going to be moving into the slope of enlightenment, using Gartner terms, where even next year we'll start to see a whole new generation of products that are gonna kind of blow our socks off.
It's super exciting. So awesome. Well, thanks for your time, man. It's great to chat with you. And for people out there, get Datapreneurs. Excellent book. Give it 5 out of 5 stars. So, yep. Awesome.
Great. Thanks, Joe.
All right. Thank you very much.